Hey, how are you guys doing? Good to see you. I think this is part 10 of Professor Rhines out in the elements. Today I'm right where, just down from where Turtle Creek comes into the Rock River. This is the Rock River right here. And where my finger is pointing right here, do you see this little dot right up here in the tree? This is an eagle's nest. Eagle's nest right here. Right out there. So while I don't know if you can see it or not, the mother is peeking out over the nest. So while I'm teaching today, at some point or another, you might see an eagle come flying in back there. You'll have to keep track of it. You'll be able to see it better than I will because my back will be to it. And yet this is only a hop, skip, and a jump from South Beloit, the Dairy Ripple, and all that going on. And yet right here, got nature doing its thing right in our backyards. So hey, we have 2 sections left that we're going to cover. You got to kind of watch out because I do have some poison ivy around me, and that would not be fun to get into. I do that too often, more than I like to say that I do. So I'm going to try to avoid that while I'm reading to you guys today. And check it out, got my whiteboard. Be able to show you some things with that. All right. I got my markers in here. Get my equipment laid out. Hopefully you guys had a good weekend. Beautiful. It's so bizarre today. I'm talking about snowflakes and snow forming and frost. And so check out my t-shirt. I wore this from a race I did here a couple of years ago. It's a half marathon. Actually, I've run it like 5 or 6 years in a row, but this is from a t-shirt back in 2017, and it shows snowflakes. And so I'm gonna be talking about how those form today. Figured it was the appropriate shirt, even though it's like 70 degrees out. All right, hey, let's get rocking. We've been reading from A Drop of Water. It's by Walter Wick. We're nearing the end. I'll be able to finish it off between today and tomorrow. All right, so this section is called Snowflakes. I feel like the color keeps coming in and out here. Maybe adjust that ever so slightly, but I want you to be able to still see that eagle's nest in my background, so maybe that's good, just like that. All right, it says the snowflake is shown 60 times its actual size. The angles between the 6 major branches are repeated over and over again in many of the smaller details of this amazing structure. How can such an intricate object form in the sky? Look at this thing. They blew that up 60 times its original size to see all the intricacies in that snowflake. Cloud droplets form when water vapor condenses. We've been talking about condensation. Condenses means it's going from a gas to a liquid. We saw that on the side of the glass the other day when I had ice water in it, and we put it near that humid air and it stuck to the side. Cloud droplets form when water vapor condenses on particles, but in very cold air, water molecules that cling to particles form tiny ice crystals. As more water molecules from the air freeze onto the crystal, they join at angles that allow a 6-sided structure to form. If the crystal grows large enough, it will fall to the ground as a snowflake. Clouds that produce snow often contain both ice crystals and liquid droplets, hence the cloud. At the center of the snowflake is a cloud droplet that froze, allowing the snowflake to form around it. Kind of like we talked about with rain the other day. Rain forms from water molecules condensing around salt and dust we had talked about. Scattered throughout are other cloud droplets that have frozen onto the snowflake as it fell throughout the cloud. Sometimes snow mixes with pellets of sleet, which are frozen raindrops like the ones shown below that I'll show you here in a second. By contrast, snowflakes are ice crystals that form when water vapor changes directly from a gas to a solid. Remember slug? Well, I'll show you that sleet picture here first. Sleet looks like that, where it's droplets that are condensing, and then the snowflake like I showed you a second ago. Remember slug? We call it slug, I don't know. I came up with that. And I capitalized the S, the L, and the G for solids, liquids, and gases. And so as part of that, what's happening is it goes directly, for a snowflake, it's going directly from water vapor to a solid. It's skipping that liquid state. Unless it's sleet. Sleet is going from the liquid to the frozen. But snowflakes, they go directly from water vapor to a solid. And so this next little section is called Endless Variety. Many ice crystals grow into shapes that are just tiny slivers, rods, or clumps of ice. Of these, the underlying six-sided structure may not always be visible, but when weather conditions are just right, the crystals will grow into an astonishing variety of elaborate six-sided designs. Isn't that bizarre that it's always six-sided? I wonder how that came to be. That water just can go from a water vapor to a solid and always be six-sided in a snowflake. Now granted, each of the sides or the legs of the snowflake could be different lengths. We'll look at that in a second, but always six-sided, six legs that come out of it. All the snowflakes on these two pages were photographed on the same day. All share the same angles, but vary in design. One has 6 branches of unequal length, giving the appearance of a 3-sided snowflake, but it really does have 6. Another snowflake has only 4 branches. Apparently 2 of the branches didn't grow all the way out. Odd variations like these are typical because different conditions of humidity, wind, temperature affect the growth of each snowflake as it fell. Each design holds secrets. Secrets of nature, secrets of the snowflake, of its unique journey to Earth from those clouds on down. When a snowflake melts, its intricate design is lost forever in a drop of water. But a snowflake can vanish in another way. It can change directly from ice back to the vapor. The sequence below shows a single snowflake as it gradually disappears. So it can go from that solid back into water vapor. There's another thing that can do that. It's called dry ice. It's not really ice. It's carbon dioxide, CO2, and we call it dry ice. Sometimes you see it all around Halloween. They'll use it to make it look like it's a brew, but it's going right into a vapor, from a solid into a vapor. When it does that, it's called sublimation. Sublimation, so different from evaporation, condensation. Sublimation's when something goes directly from a solid into a gas. Let me show you some of those snowflakes here. These were, remember, they said all filmed on the same day. Here's that four-legged one. This one and this one didn't form all the way. This one, it looks like it's 3, but it's just because this one, and this one didn't form all the way. It really is 6. And then some down here. All unique in their own way. And then down here, you can see how it starts as a snowflake and it gradually goes into water vapor and just disappears. That's pretty cool. For a raindrop, we talked a little bit about that the other day, and I mentioned it a second ago, where it could just start off a dust or salt particle in the air, and the H2O molecules, microscopic things, just keep going around it and around it and around it until it can get to the point of being a raindrop. But they're saying snow, it condenses around that from just a droplet of water, and then the others come around it, forming those 6-sided snowflakes. All right, last page. This one's frost and dew. On some days when the air is humid, a sudden drop in temperature during the night will cause water vapor to condense. You might feel this sometimes if you walk out on your lawn in the morning and the grass is wet. So the water vapor condenses on cold surfaces like that grass. By morning, the landscape is covered in sparkling drops of water called dew, D-E-W. If temperatures fall below freezing, the cold weather relative of dew appears, and that's called frost. On windows, frost forms along tiny scratches and other imperfections in the glass. As with snowflakes, frost is the result of water vapor changing from a gas to a solid. That's why the angular structures of ice crystals is evident in the fern-like patterns of frost. Look at those fern-like patterns where they kind of go wispy out on the ends like a fern does. When dew forms, a short walk through the grass will soak your feet. On spider webs, dewdrops appear like glistening pearls. You can see that on the spider web. It's cool, it makes intricate patterns. In this photograph, we can see how the water reflects and bends light. An upside down landscape appears in each droplet of water on that spider web. I don't think I can get that close, but on each one it makes little reflections of the landscape around it. In fact, that's kind of you can sometimes tell when it's going to rain. At least that's one way you can figure it out, is besides looking at the news these days or looking up in the sky. If you come out and there is snow in the early morning, because some of you maybe get up late and by then it's dried up, but if you get up in the early morning and you go out on your grass in your bare feet and it's dry and there is no dew, there's a good chance, not always, but there's a good chance there'll be rain on that particular day. But otherwise that dew forms on there. Another way that it can go from one state of matter to another, between those solids, the liquids and gases, and freezing on there, instead of being dew, it'll be frost. So a little bit with snowflakes, a little bit of frost. That's why Mr. Rhines wore the shirt like he did today. All right here at the confluence, another confluence. I was there 2 days ago on the confluence between the Pecatonic and the Rock, and this one's where Turtle Creek and the Rock come together, right here on this island, with an eagle watching me from the nest up there. That's pretty cool. So as we like to say, peace out. We love you guys, and we'll see you along the way.